Welcome. In this video I will show you how to use serial wire viewer printf debugging on the STM32F767ZI Nucleo board using STM32CubeIDE. We will blink some LEDs and the print message over the ITM console. No UART needed. You can see here this message is displaying here as the LEDs are blinking. Message you can write anything. So I write here, Sister Fifi, I love you. Any message you can write. So what is the main purpose of the print is you should show the LED 1, LED 2 which is blinking or toggling or fading. I just write as a fun, so any message you can write. What is SWV? SWV stands for serial wire viewer, the part of ARM Cortex-M debugging system. So when you use the debug pins, it is here disabled. When you select serial wire, PA13 and PA14 will be enabled. And also after that you go to GPIO and you can go to sys, and here you can see PA13 and PA14 is enabled. Here you can see I use the PB0 as an output, PB7 as an output LED blue. The third LED I use PB14 LED red. 3 LEDs I will blink, I will toggle, and with each toggle you can see it will appear one message on serial wire viewer. Use printf function to log each toggle. Add write function for ITM redirection. So this line of code I am using here in user code begin 4 in which is automatically generated code by the this one is low level system call that printf uses to send output data. This function you can find here in go to src source code and syscall. Here you can find this function. This function overrides the default write system call from syscall. It redirects the output of function like printf to specific output device. In this case, the ITM simulate port 0 used by serial wire viewer. So send each character via ITM send char, which writes simulus port 0 used by serial wire viewer. So why we use printf? By default, printf has no idea where to send its output. STM32 HAL does not route printf anywhere unless you implement this _write function. This function hooks into the printf mechanism and allow you to view output in the STM32CubeIDE SWV ITM console. Also I will write this line of code in the description. Also you can get from the GitHub. So another necessary thing how to do this one, just go to your project, right click, debug as, and debug configuration. Here you can find it will go to the main. This is your project name. Go to the debugger and make sure your clock core is matching with your board processor MCU. Also you need to enable this one serial wire viewer, enable it, and this clock core 96 MHz. This you can confirm. Go to the IOC file. Here go to the clock configuration, and here you will find this click 96 MHz is there. And same thing you need to select. Next is how to view this port 0 SWV ITM console. So simply go to window, show view. Here you can see here it is missing. Sometimes it is missing, sometimes it is available. How to get this one? Go to the others and you will find here SWV. Then in SWV go to this one SWV item data console, and it is already open here, but I'm show you how to see this one. Now you can see here it is not there. The same way you can get it from there. Okay, when it is display, this is the procedure. Go to Windows, show view, serial wire viewer, serial wire ITM console. Next step is you will start trace from here. Now you can see here it is not enabled. So how to do this one? Go to the debug. After debugging, you will see here this message will come and download successfully. Now you go here, SWV item data console, go to the setting. In the setting you will see here system code clock 96, and you need to check this one 0 port, ITM stimulus ports, check this 0, click OK. Now you will see here it is displayed. Okay, I will show you another example. Okay, I am selecting port 31. Okay, in ITM console now you can see port 31 also is available here. So our requirement is only port 0. After that, select this one, start trace. When you start trace, it will start trace. After that, go and resume, press F8. So how to do this one? Go and here run debug item data console, start trace, resume, and you will see it will display all the messages. So now I will show you the in main file. At first I include studio.h. So I include studio.h to use the standard input output function in C language. Why we are putting STM32 bare metal embedded system, if you want to use printf function to send debug message like SWV printf ITM console or UART, you still need to include studio.h, because printf is the function, is the part of standard C library that is defined in studio.h, and STM32 all does not replace printf or provide its own IO function. It expects you to integrate it with a backend like UART or SWV using write function. Next line of code I use here, user code begin PFP. This code I use, which is serial wire viewer initialize. PFP I write here, it is stand for private function prototype. It is the section where you declare prototype of your custom function like void SWV initialize void, so the compiler knows about them before main uses them. Serial wire initialize void sets up serial wire viewer debugging interface on ARM Cortex-M cores like STM32, especially enabling ITM instrumentation trace macro cell output for printf style debugging through STM32CubeIDE SWV console. And second line of code, you can see code debug DEMCR. This enables the trace system by setting the trace NA bit in the debug exception and monitor control register. This allows access to trace feature like DWT, ITM, TPIU. And next line is ITM LAR, and this line of code, this is unlock the ITM instrumentation trace macro cell by writing the required key to the log access register LAR. Without unlocking the most ITR features are inaccessible. And the next three line of code, ITM ENA main enable bit, TSENMA timestamp enable, add timing into the trace packets, and SYNCENA synchronization packet enable help tool like STM32CubeIDE keep the timeline accurate. Then here the last line of code, ITM ER enables stimulus port 0, which is the port used by ITM send char, use initially in write to output character. Without enabling this, no output will appear in the serial wire viewer. even if everything else is configured. So SWV initialize, it is essential to make printf over SWV work it. Enable trace port, unlock and enables ITM, set up stimulus ports 0, allow tools to like STM32CubeIDE to display printf message in SWV ITM console. So main things, first we include studio.h. Second thing, I write this code in private function prototype. Serial wire viewer initialize must be done in exact series for serial wire viewer output to work correctly. Why it required? This must come first without the ITM, and other debug component are completely disabled. Then we unlock ITM LAR. Here we unlock the ITM. Then enable ITM core and features with this code. Then we enable the port 0, and here is our beam code like toggling the LED. This already your experience. Only what is different, so this is normal GPIO port, pin and delay and toggle, this you know already. Only the line here printf, and whatever you want you can write in this one and it will display, and it will display here. You can see here it is display. Example flowchart I can show you here. We start SWV initialize, enable track system in code debugging. This have we done. This we did. Then enable ITM instrumentation trace function. This is done by ITM LAR, and this line of code. This enable ITM and features, and after that enable stimulus port 0 as I show you before. Then SWV ITM ready to use, and printf you can see ITM set char. This is temporary. I am showing you this